Good afternoon. I'm Yevhenii Yaremchenko. Let me present the results of the realization of education online virtual learning environment for learning basics of Internet of Things technologies. During this presentation, we will discuss the results of investigation and development of online virtual learning environment, or VLE, for Internet of Things technology study. The application of this environment will provide students with knowledge and skills necessary for selection and of components and protocols for IoT systems realization, as well as for the organization of users' interaction with IoT applications. The introduction of the Internet of Things technologies in industrial production allows enterprises and companies to reduce operation costs, increase production uptime, and accordingly increase production volumes and reduce its costs. Therefore, the further development of the IoT technologies is an urgent task for both scientists and industrialists. In the context of distance learning, mastering the IoT technologies is especially problematic due to the complex organization of remote practical experiments with components, protocols, hardware, and software platforms used during the implementation of the IoT systems. Thus, the development and application of online engineering technologies and tools for the IoT system studying are up to date. As the studies have shown, different teaching methods and learning resources based on online engineering technologies can be used successfully for training in the field of the IoT. Each of them has its own functionality, advantages, and disadvantages. Existing virtual laboratories offer experiments focused on specific programming problems for IoT devices based on different hardware platforms. These virtual laboratories are mostly presented as web clients, as such systems are fairly easy to implement for usage in a web browser. Existing virtual environments offer more possibilities to the user based on the free exploration of the virtual world and performing various tasks in it. Most of them are presented as desktop application or clients, so they require installation on the user's computers. Thus, the tasks of further development of online learning environment for organizing virtual experiments in the area of the IoT technologies is relevant. The goals of this work are research and practical implementation of online virtual environment for the IoT technology study. To organize the interaction of users with online VLE, it's advisable to implement several graphical user interface and WIMP paradigm methods. It should be implemented such WIMP methods as point and click, select and highlight. In addition, it's necessary to use specific for VLE interactions methods. Heads-up display or HUD on which the actual data, error messages, information widgets, and widgets for performance curtain actions are visualized. Perspective of observing an agent is top-down. Computer mouse to organize agent movement inside VLE. However, a set of basic methods for organizing user interaction with the VLE should be improved by introducing a remote user interface and a remote programming method. The remote programming method is a method of user interaction with the system, which consists in using a programming language to send commands to the system based on online technologies. The application of the remote programming method for interaction with the system allows the user to develop external programs that can control the full range of the IoT system functions. A typical approach to this method implementation is the usage of TCP/IP socket and any programming language with built-in capabilities or methods for working with them. Based on literature review, it was decided to implement virtual learning environment for the IoT technology study as a non-immersive online system in the form of a web client i.e. HTML5 compatible program for using in a regular browser. This approach does not require the application of additional control devices, high computing power, and installation of software on users' computers. The system is built on the basis of a client-server architecture that combines a server and a virtual learning environment. The Node.js platform, the Express.js framework, the JavaScript and TypeScript programming languages, and the Visual Studio Code IDE were chosen as the system server development toolkit. To implement online virtual environment, the game engine Unreal Engine 4 was chosen, which provides a high level of graphic capabilities, ready-made templates and models, textures and materials for them. It's important that with the help of this game engine, it is possible to create applications for web browsers that is HTML5 compatible programs. After connection of hardware and software clients to virtual environment, user can interact with the both, and the result of such interaction affects on another part. In case of user interaction with hardware and software clients, or HST, which is developed by himself, such clients should handle the action. To ensure the possibility of remote interaction with the developed system, the data transmission protocols used in the IoT systems were analyzed. The investigation have shown that protocols are an integral part of the technology stack or used in such systems. In the context of the development of VLE, which should provide the opportunity to gain practical skills in development hardware and software for working with IoT systems, it was necessary to analyze application layer data transmission protocols because users and his clients directly interact with them. The investigations have shown that the Mqtt data transfer protocol can provide reliable and secure routing for small and cheap devices with low power consumption and memory in unstable and low bandwidth networks. Therefore, the Mqtt application level data transfer protocol can be recommended for organizing remote interaction between virtual learning environment and users' clients, because this popular and reliable protocol is often used in the IoT systems. Implemented virtual learning environment is a non-immersion system in the form of a web client to run in Google Chrome and Mozilla Firefox web browsers. The developed software provides the functions of simulating virtual learning environment and its equipment, using the example of home automation system, as well as the possibilities for user interaction with them. This virtual environment initiates actions on the session by sending requests about this to the server using its REST API. It also displays the parameter for connecting the user's clients, the message exchange log, and other information to the user. For the server, the structure of entry points for communication between the server and virtual learning environment was developed. The naming rules and the structure of Mqtt equipment topics, as well as the rules for publishing in them, were determined for virtual learning environment. In order to be able to control the events that take place in the home automation system reproduced in a virtual learning environment, as well as to create them, the structure of Mqtt topics was implemented. Analysis of the possibilities of using the product showed that the user can interact with the developed VLE using hardware as well as self-developed or ready-made software applications. To ensure compatibility between the client and the server of the system, students' clients must be able to work with TCP or IP sockets using the Mqtt data transfer protocol. A software client is software that allows the user to perform actions in a VLE by passing commands to it. The most common type of software clients are mobile applications. A hardware client is a device that provides various physical tools to interact with VLE. Such tools include simple buttons as well as various sensors, lighting, temperature, etc., based on which the software component of such clients can interact with VLE. In addition to developing their own applications, the user can use existing solutions, such as a free Mqtt client, which is presented on the slide. The experimental representation of the system data is presented in table. For today, the number of implemented standard Mqtt subsystems is limited. This is due to the complexity and duration of the development of virtual models of equipment, which often requires the implementation of a mathematical model of physical processes. For example, a mathematical model of room temperature measurement results changing. As a result of the performed research, the features of existing methods and tools of online engineering for studying IoT technologies were identified. The developed line VLE is intended for teaching and learning the development of software and hardware for interacting with the IoT systems, conducting remote experiments on developing clients for working with the IoT systems, as well as creating and testing the operability and efficiency of control scenarios. The practical value of the work lies in the fact that the implemented VLE, which is based on improved method, provides a tool for developing practical skills for programmable interaction with the IoT systems using hardware and software clients. In the future, it's planned to increase the number of available components of VLE, in particular for industrial IoT systems, as well as to implement new possibilities for user interaction with a virtual learning environment. Thank you for your attention.